All right, so this is going to be a video all about practice problems involving horizontal asymptotes. So let's get started on it. This first question says, what are horizontal asymptotes and how are they found? And then I wrote the answer in there already. It says horizontal asymptotes are horizontal lines that a curve approaches but never reaches as it heads toward infinity or negative infinity. So it could be either one of those or both of those. And what I'm going to do really quick here is just draw an example of what a horizontal asymptote is, just to kind of put some visuals on that concept that I was just talking about. Say I had some function that looked like, let's just say it went up like this, and then it kind of flatlined here and just did this. Okay, and where it's flatlining, it's actually approaching, let's just say y equals 3. Okay, so you can imagine a horizontal line like right here, and this graph of f, let's just say this red right here is f, it's approaching or getting infinitesimally closer to this horizontal line of y equals 3, but never actually reaching it. The asymptote, the horizontal asymptote for this problem would be y equals 3, because f is getting infinitesimally closer to 3 but never reaching it. Okay, now you can have these where they go in the opposite direction to negative infinity. So say I had this right here, and let's just say that this is, I don't know, -4, it doesn't really matter. This is just a sketch, but you can imagine a horizontal line going across here, and f is getting infinitesimally closer to that y equals -4. That would be the other horizontal asymptote for this. So it is important to understand that not all graphs have horizontal asymptotes. This one in particular has 2, but it could be possible where they have none or they just have 1. It's kind of either any of those combinations. It can either be 2, 1, or 0 for the horizontal asymptotes. All right, number 2, it says, how are horizontal asymptotes related to end behavior? And then I wrote the answer in here already. It says, if the end behavior of a function is approaching a constant y value, then the y value represents the horizontal asymptote. If you notice, it does say approaching here. Okay, that is a key word. It's not actually equal to a constant value. It's just approaching. It's getting infinitesimally closer to a constant value. And I kind of talked about that over here. If you notice this end of the graph, so that for the end behavior going this way, if you notice, it's approaching 3, okay? The other end of the graph over here is approaching -4, y equals -4. So that's kind of how end behavior relates to horizontal asymptotes. If the ends of a graph are approaching a specific value, then those values represent the horizontal asymptote. Okay, so that's number 2. Number 3, it says, consider the rational function f of x, find the equations of all the horizontal asymptotes of f. Okay, the main concept when you're finding horizontal asymptotes involves this limit property. Okay, this was talked about in class, but what you're doing is you're taking the limit of x as it approaches infinity of this f of x function. So I'm just going to write that in here really quick. X plus 1, x minus 2, x minus 2, and x plus 3. Now, since we are going to infinity, it allows us to do some very, very, very simplified math, because any other number that's not a variable is kind of meaningless because we are going to infinity. Okay, because we are going to infinity, all other numbers that are just constant are kind of meaningless. So this number is kind of meaningless, this number, and this number. And again, it's because x is getting infinitesimally big. So we have x plus 1 for this first one right here, this first factor. That 1 is meaningless because x is going to infinity first. So for all intents and purposes, you can just get rid of that 1. Okay, x minus 2, infinity minus 2, you can get rid of that 2. You can get rid of this 2. You can get rid of this 3. Okay, and then what you end up with is an x times x up top and an x times x on the bottom. So you end up with x squared over x squared. Okay, well that makes the math pretty simple, and your answer is just 1 for that. But it says find the equations of all the horizontal asymptotes. You have to write a y equals in there. So y equals 1 would be your answer for this one. Okay. Now it is also important to understand that you can't have asymptotes going both ways. So besides infinity, you're also going to want to check negative infinity. So we're going to do the limit as x approaches negative infinity of this same graph, this same rational function. Okay, well the same rules apply. Okay, since we're going to negative infinity, that 1 is meaningless, the negative 2 is meaningless, negative 2, again, they're meaningless, and this 3 is all meaningless. So you end up with, again, you have a x squared on top. This all cancels. And then you have an x squared on the bottom. Okay, well, x squared over x squared is going to get you 1. So again, we have y equals 1 for the horizontal asymptote. Now, you don't really need to write this twice. If you wrote it once, it's totally fine, but the horizontal asymptote for this one would be y equals 1. Now, what does that look like as a graph? Well, let's check it out really quick. I'll graph it on Desmos. All right, well, let's check this out in the graph and make sure that these are, in fact, the horizontal asymptotes, and we'll just get a better idea of what this thing looks like. So we have f of x is equal to x plus 1 times x minus 2, and then we're dividing by x minus 2 and x plus 3. Okay, let me blow this up a little bit. All right, now if you notice, it looks like it's approaching some specific value going to the right and some specific value going to the left. So what we can do here is we can do f of, let's just say f of 1, but we're trying to go to infinity for x. So we don't want just 1, let's make it 10, and then let's make it 100, and let's make it 1,000. If you notice, this y value is approaching a specific value as I get closer and closer to infinity. So let's rewind here. We're gonna go to 1, 10, 100, 1,000. You should notice a certain pattern here. It's getting infinitesimally closer and closer to some value. And if you wanted to, you can overload your calculator here. Eventually it's going to round it off to 1 because it runs out of memory for that. But let's do the same thing with going the opposite direction. So we'll start with negative 1, and then we'll just get a value that's going closer and closer to negative infinity. And you'll notice it's getting closer and closer to 1 on the opposite side. So one's 0.999, the other one's 1.00000. Again, if you overload this, eventually it just rounds it off to 1. But this definitely shows us that what we're doing is right because it matches the graph. Our results match the graph. Now let's do this. Let's do y is equal to 1. Okay, now we actually graphed the horizontal asymptote on there, and if you notice, let me zoom out a little bit, it's getting infinitesimally closer to 1 on both sides, so y equals 1, it does make sense as the horizontal asymptote for this problem. Now this comes up pretty nice in Desmos. It doesn't come out as nice on your TI-84 calculator, but I still want to show you this just because you can use this on assessments to check your work when you're doing these problems. Now, since you're not allowed to use Desmos on a test, I do want to show you how to do this on your TI-84 calculator really quick as well. So you're going to want to graph it first. So I'm going to go into the y equals. So you're going to want to graph it first. So we're going to hit the y equals in here, and we are going to put that function in there. And it's going to be, what is it? Let's do alpha y equals to get the fraction in here, and we're going to do x plus 1 parentheses x minus 2 parentheses. Go down here, it's going to be x minus 2 parentheses and x plus 3 parentheses. Okay, and then I'm going to graph this here, and you'll notice it looks similar to what we just did on Desmos. Okay, so you notice there is definitely a horizontal asymptote going on. It looks like it's y equals 1. It's hard to tell. So what you could do is you can graph y equals 1 if you want. So throw a 1 in there and trace that. You can kind of see that it does get infinitesimally closer to that 1, but never actually reaches it. Another thing you can do is if you go to your table set right here, so hit second window and go to table set and make sure your independent is set to ask. Okay, so what it's going to do is it's going to ask for the independent variable, which is the x. So we're going to go to this table here, and I'm going to put in values that are getting infinitesimally closer to infinity and negative infinity. So it's going to kind of match what we did in Desmos. So we're going to put a 1 in there, hit enter. Then you can hit 10, throw that in there. Okay, if you notice it's coming out as fractions, I don't want that doing that. So we're going to go to mode, and I'm going to change this to where it says answers. I'm going to change that to say decimal because it gives us a better idea of what we're approaching here. So go to the graph. So if you notice, the y1 is what we're looking for. We're looking for a pattern as we go to infinity. So we're going to go to 100. Okay, we're going to gonna go to 1,000 here. If you notice, it's approaching 1. Okay, now let's go to the other side. So -1, -10, -100, -1,000. Okay, you'll notice it's getting closer to 1 as you approach infinity on one side, and on the other side for negative infinity, it's getting closer to 1 as well. So that shows us that we are doing the problem correctly with that horizontal asymptote. So y equals 1 for both of those. Okay, number 4, it says find the horizontal asymptotes for the following function. So we have this function right here. Okay, one thing that I do want you to notice right away is that the power on the top, the degree on top is 2, the degree on the bottom is 3. So that means there's going to be a bigger infinity on the bottom. If you have a bigger infinity on the bottom, it's going to approach 0. Okay, so I'm just going to say that y equals 0 here just to start that off as the answer. Now that's looking at it conceptually. Let's break it down a little bit more algebraically. All right, so we're going to do the limit as x approaches infinity of x squared minus 3 all over x to the third. Okay, the same rule applies as we did before. This 3 is basically meaningless, so we're going to get rid of it. And then you're going to be left with x squared over x to the third. So we're going to divide the top by x squared, which is 1, divide the bottom by x squared, which is x. So you're going to be left with 1 over x for your fraction, for this rational function right here, this rational expression right here. Now, if you have 1 of something and you divide it by infinitely many, because if you remember, this x is going to infinity. So if you do 1 divided by infinity, just imagine you had 1 pizza and you divided it by infinitely many people. Each person would essentially get nothing. Okay, so that would be 0 here, and y equals 0. If you notice, it matches what we had originally by using the principle of the degree on the bottom is bigger. Okay, if the degree on the bottom, the denominator is bigger than the top, it's always going to be y equals 0 like this. Now, if you want, you could also test it out by going to negative infinity and making sure that the answer still works. Okay, so you're gonna have x squared minus 3 all over x cubed. Okay, well the 3 again is meaningless. You again have the x squared and x to the third, break down to 1 over x. If you plugged in negative infinity at the bottom, it would be 1 divided by negative infinity. It still ends up being 0 because you're dividing by a bigger and bigger number. It's just a bigger and bigger negative number. So again, either way, you're still gonna be left with y equals 0 for that. All right, let's check Desmos to see what's going on here. We have x squared minus 3 over x to the third. Okay, let's get rid of this for now. If you notice, it's approaching, it's getting infinitesimally closer to that 0 here. If you zoom in, you'll see that it's actually not as close as it looks here. It's just zoomed out. But if you zoom in, it doesn't matter how far you get from this. So here, let's actually go all the way over here to like 125. If you zoom in, you'll notice there is still a little bit of separation. You just have to zoom in a little bit to make sure that it's there. All right, now if you notice, when I plugged in a super huge number to go to infinity, you'll notice that it's approaching a specific value. So at 1, it's negative 2. Let's go 10, 100. It's just getting smaller and smaller and smaller and smaller. It's approaching 0 essentially. If you overload it, I think it would eventually reach 0. Let me check. It's doing scientific notation here, so it might not. This might be a waste of time. Yep, there you go. Finally, it maxes out to 0 here. This one does the same thing. If you go start at negative 1 and then just make it bigger and bigger negative infinity, it goes to 0 as well, but I'm not going to waste your time on that. So if you graph this, y equals 0, let's test it out. We graph it, you'll notice it approaches from both sides, so it does work out for that problem. All right, let's go to the next one here. It says find the horizontal asymptotes for the following function. So we're doing this one right here. Okay, right away you can see that the power on the top is going to be bigger than the bottom because there's 2 x's. There's this x here and this x here, and there's only 1 on the bottom. When you multiply those x's on the top, it's going to be x squared, so it's going to have a bigger power on top than on the bottom. Whenever this happens, there is going to be no horizontal asymptote. Okay, whenever the degree on the top is bigger than the degree on the bottom. So at the top, we're squared. At the bottom, we're just x to the first. So because of that, it's no horizontal asymptote. Now I'm going to actually show this a little bit more algebraically here so you understand. So we're going x going to infinity, and we have x minus 1 times 2x plus 7 all over x minus 1. Now we're going to infinity, so that makes some numbers just kind of meaningless. This one, and this one are all meaningless. So at the top of this, you are going to end up with 2x squared. So at the top of this, you're gonna end up with 2x squared here. So cancel. At the bottom, you're just gonna be left with x. Okay, well, when you divide the top and the bottom by x, you end up with 2x over 1. Well, x is going to infinity, so 2 times infinity would be infinity. Okay, so your limit for this would be infinity, but this does not represent a horizontal asymptote because as we talked about before, it has to be getting closer and closer to a specific value. Infinity is not a specific value because it's continually increasing. So because of that, that's why there's no horizontal asymptote. Now, just to be 100% sure, I am going to test the other side as well. So we're doing the limit as x goes to negative infinity, and we have the x minus 1, the 2x plus 7, and we're dividing it by x minus 1. Okay, again, so again, meaningless. We have 2x squared on top, and then x on the bottom. If we simplify this out, divide by x, you have 2x over 1 again. 2x times negative infinity would be negative infinity here. Either way, again, it's still no horizontal asymptote. Do not write infinity or negative infinity as your answer because they're technically not horizontal asymptotes. Now, what does this look like as a graph? Well, let's check it out. So we are going to have x minus 1 times 2x plus 7, and then divide this by x minus 1. Okay, let's get rid of these values here. And we're trying to see what going to infinity looks like. So if we plug f of 1 in there, it's undefined, but what about 10? Okay, 27, okay, 100, 207, okay, 2007. We're just gonna keep adding more and more zeros. If you notice, it's not approaching a specific value. It's just going higher and higher and higher the entire time. Let's do the same thing with this one. Looks like it's getting more and more negative each time. Okay, it's not approaching a specific value. It's not getting infinitesimally closer to some number. And if you look at the graph, it makes sense. It's going up forever. Okay, it's going to the right and up forever, and then down to the bottom forever on the left, okay? So because of that, there isn't going to be a horizontal asymptote because it's not flatlining anywhere. It's not approaching a specific value, so that's why you would write no horizontal asymptotes. So that's a quick video on horizontal asymptotes. If you have any questions about anything in this video, let me know.